Hi, my name is Isaac Grimes.
And my name is Paris Williams, and our project is fingerprint analysis. Will gases, powders, or chemical solutions have the most accurate fingerprint analysis? Like any, like another method of forensic science that has been applied to solve crimes across the world. However, there has been a little research done to explore the details of fingerprinting and the start of fingerprinting. This paper explains in a very detailed way the different solutions, powders, and chemicals it takes to have a fine fingerprint. It will present and discuss the finding of fingerprints and how it's used today. After presenting some of the research and knowledge of this approach to forensic science, the result from research will provide a standard used to compare results done by tests. Silver nitrate, according to United States Forensic Science Laboratory, is used most often out of 4 common ways to collect fingerprints, meaning that its outcome should be better. Gases. Iodine is an element that is naturally in some foods that is found in some salts. Iodine also needed for production of thyroid hormone. If you don't have enough iodine in your body, you cannot make enough thyroid hormone. This can lead to iodine deficiency, which can cause an enlargement of thyroid disabilities in infants and children whose mothers were iodine deficient during pregnancy. Iodine is also used for fingerprints. This is called iodine fuming. In development, Latin prints with a long used method, iodine crystals give off vapors that absorb physically to the oil substances of a fingerprint. The brown color prints that are developed with iodine are not permanent unless fixed. Chemicals. Silver nitrate is an inorganic compound with a chemical formula AgNO3. Silver nitrate is used in the forensic land for fingerprints. This can be used on cardboard and paper. Silver nitrate can be sprayed onto the fingerprints where it reacts with the chlorides in the skin secretions. Nihydrin is a chemical powder that is soluble in ethanol or acetone at room temperature. When a solution of nihydrin is applied to fingerprints, the nihydrin reacts with amino acids that are present in fingerprint residue. This could take up to days. Powders, Latin prints in the skin found on fingers, palms, and soles of the feet of humans, also known as friction skin. Latin prints are not visible to the naked eye. Fingerprint powders develop or make the prints visible. These powders are made with inorganic chemicals such as lead, mercury, cadmium, copper, silicone, titanium, and bismuth. This powder is applied by brushing it onto the surface and working by adhering to oil and moisture components of Latin prints. It causes them to become visible.
Our question for this project was, will either gases, powders, or chemical solutions have the most accurate outcome on fingerprints? Our hypothesis was, it is hypothesized that chemicals will have a better percentage of accuracy for acquiring fingerprints because chemicals are known for containing many substances and solutions in science in general and science research. Our material list includes 4 beakers that are 250 mLs, glass slides, fume hoods, latex gloves, distilled water, cyanacrylic glass powders, iodine gas, lab coat, safety goggles. Protocol. We gathered all chemical solutions and gases and powders for getting the fingerprints and applied the fingerprints to 3 different surfaces, including glass, metal, and wood. We analyzed the fingerprint overall and how it came out and if it stayed long enough and if it was able to be identified. And we calculated the overall percentage of fingerprint accuracy. For cyanacrylic, we took 3 glass slides and applied fingerprints, put slides into the beaker and hung on a string, applied cyanacrylic metal to the metal pan, and surrounded the pan with 1 milliliter of distilled water, heated at 60 degrees Celsius. And with powders, we applied condensation to finger and made multiple fingerprints across a glass beaker, swirled around the powders in different colors of red, black, and silver onto beakers and revealed fingerprints. And with liquids, we made the solution via a recipe and placed 3 fingerprints on paper and cardboard, dipped the paper into silver nitrate and then hydrogen solutions, then sprayed both solutions onto the cardboard. Data analysis. All data was collected by averages based on the clarity of the fingerprints. Silver nitrate was 9 out of 10. The final result came out clear and visible, and the only problem was the fingerprint was lighter than expected. And hydrogen was 3 out of 10. It showed the outer outline of the fingerprint, but didn't show any detail and weren't able to identify the type of fingerprint. Color powders were 8 out of 10. They showed the entire fingerprint in its detail, making it easier to identify, but only showed the reflection of lights from certain angles. Cyanide acrylic gas was 9 out of 10. Also, it showed the full detail fingerprints and was easy to identify fingerprints. Only problem was the gas also had extra gas around the fingerprints. Even though that simple flaw, the fingerprint was still clear and easy to identify. This is our chart, just reiterating the averages I just talked about. And in conclusion, the initial hypothesis was right and sort of wrong at the same time. Technically, the research proved that cyanide gas was the best and had the most accurate fingerprint. The cyanide gas covers the entire fingerprint in full detail, making it easier to identify. Results from the silver nitrate were good and correct, but the detail and clearness of the fingerprint were less accurate than the gas. The fingerprint came out completely right, but not as correct as the cyanide gas. The hypothesis was wrong in the sense that it was a gas with the best result, but also right because to make the cyanide gas, it requires a solution. Experimental errors were that the silver nitrate and hydrogen required either a UV ray machine or sunlight. Unfortunately, there was no possible way to access this machine or find one. There was access to sunlight, but not for as many trials as we wanted, but the results were just fine. Future studies include using more hard and rigorous chemicals solutions to see if they work. And chemicals like iodine, black ferric oxide, and rosin to get an even more in-depth look at studies and works of forensic scientists. And we didn't use them this time because of our lab accessibility, and they're very dangerous. And that is it. Thank you.
You said thank you.